All right, let's dive right in. Today, we're going to talk about something that's on the edge of AI development: how to build truly specialized, expert level AI. We're going to break down Codada's framework, which is all about getting past the limits we're seeing today.
So let's just start with the big central problem. I mean, we have these incredibly powerful AI models, right? But it feels like they're starting to hit a wall, a kind of performance ceiling. So why? What's stopping them from getting even better, even smarter? That's the core question we're going to unpack.
And the issue really comes down to this idea of an AI performance ceiling. The culprit, and this is kind of ironic, is the very thing that made these models so powerful to begin with: the internet. They're basically just learning from a massive but ultimately limited pool of recycled public text.
And you know, this is a huge shift in thinking. For years, the mantra was just more data, right? Just scrape more of the web. But we've hit a point of diminishing returns. The models just stop getting better because the real bottleneck isn't the quantity of data anymore. It's all about the quality and the novelty.
Okay, so if scraping recycled data is the problem, what's the solution? Well, it starts with building a totally new foundation. And that brings us to the first stage of the process: meticulously assembling verifiable, trustworthy data right from scratch. The whole thing works like a three-step pipeline. It all begins with what they call atomic contributions from real human experts. Think of these as tiny, specific little nuggets of knowledge: a sample, a label, a quick validation. Then, those are bundled up into reproducible data assets. And finally, those assets are organized into versioned data sets where you can track the history of every single piece. It's like building with precision-engineered Legos instead of just scooping up a bucket of sand. Now, what this pipeline gives you is a set of guarantees you could never, ever get from just scraping the web. Determinism means the whole process is repeatable and predictable. Immutability means the data can't be tampered with after the fact, and you get full provenance. You know exactly where every single piece of information came from. It creates this verifiable chain of trust from the human expert all the way to the final model. Okay, so with that trustworthy pipeline in place, we can finally start creating the high-octane fuel we need to blast past that performance ceiling. And this special kind of fuel, it has a name. It's called frontier data. So what in the world is frontier data? The definition here is absolutely key. This is the kind of knowledge that you literally cannot find and scrape online. It just doesn't exist in that format. It has to be purpose-built, piece by piece, by actual human experts. And just as important, it comes with that verifiable history and clear ownership, which is honestly a total game changer. Let's make this a bit more tangible, though. Think about the subtle, precise hand movements in a robotic surgery, or the multi-step logic that goes into a really complex financial trade. What about the deep, nuanced understanding of cultural context that a human just gets? Or super specific, edge case scientific knowledge? You're not going to find that stuff in a blog post. It has to come from people who live and breathe that world every single day. So now we have the fuel, this incredible frontier data. The next logical step is to use that fuel to forge a general AI model into a true domain specialist. It's like taking a super smart college grad and turning them into a world-class surgeon or a top-tier financial analyst. And to do this, Codada uses a four-part framework. First up is fine-tuning, where you're adjusting the model's core knowledge with all this new data. Next, you've got RAG, which lets the model pull in specific external facts right when it needs them. Then expert prompting teaches it how to reason and respond like a specialist. And finally, and this is crucial, evaluation, where human experts actually test and rank the model's performance, which creates this amazing feedback loop so it just keeps getting better. And here it is. This is the single most important takeaway from this entire process. Every single part of that four-step framework, the fine-tuning, the RAG, the prompting, the evaluation, it's all powered by that one upstream input: knowledge contributed by human experts. The whole system is built on that foundation. So, does this human-first approach actually work at scale? I mean, it sounds great in theory, but what about in practice? Well, let's look at the milestone that really proves the whole thesis behind this system: 10 million. As of March 2026, over 10 million individual contributions, those little atomic pieces of expert knowledge, have been fed into the network. So this isn't some theoretical concept on a whiteboard. It's a massive, real-world data engineering project, all powered by a global network of human experts. And that really brings us to the core message, the thread that ties all of this together. Models and algorithms, they're going to change. They're going to evolve. But this is the one constant. Verified human knowledge is the foundational, truly irreplaceable input that's going to drive the next wave of artificial intelligence.
Which really leaves us with a fascinating final question, doesn't it? If this approach can create an AI expert in something as complex as surgery or finance, what comes next? What other incredibly complex frontiers of human knowledge are we going to unlock with this fusion of verified human expertise and machine intelligence?